All right, in this video, what we're going to do is uh, we're going to estimate the single factor risk model, or we're going to talk about how we would go about estimating the single factor risk model. This will be important because in chapter 9, we're going to talk about the capital asset pricing model, which most of you understand and know from previous finance courses. Well, the capital asset pricing model is just the most common single factor risk model, and we're going to estimate that when using actual data. But what we're going to do is we're going to talk about how we would go about estimating it. Recall that this is the single factor risk model right here, okay? So this is the single factor risk model. We have the returns for any asset I is going to be equal to the expectation of returns by the investor. And then we've introduced this risk factor, this systematic risk factor, and we've talked about how in the last video how each firm has exposure to that risk factor, and that exposure is different for some firms. In the last video, we used the example of the coronavirus pandemic, and we suggested that asset I, if it's equal to Walmart, Walmart has very different exposure to the pandemic than say Apple or say Tesla, right? And so it's important to understand and differentiate the exposure that each individual asset has to that systematic risk event. Of course, this error term is important. This error term basically says that we have expectations about what we think the return should be, and most of the time we're wrong, and that's going to be captured in this error term. All right. We talked about what the systematic risk is, right? What the idiosyncratic risk is, and that the covariance between asset I and asset J is going to likely be positive, which means there's going to be positive co-movement, or that the single factor model generates positive co-movement, and that actually harms our optimal portfolio. So how do we estimate this equation? What we'll do is we're going to get data for the returns for each asset, and we're also going to get we're going to try to measure that systematic risk event, and we're going to talk about ways that we can measure that systematic risk event, particularly in chapters 9 and 10. Okay, but let's say that we found a proxy to measure that systematic risk event. We're going to get historical data, we're going to plot that data, and we're going to run a regression that fits a line, okay, that minimizes the squared difference between each historical data point and that line. Okay. We're going to get a slope coefficient. We'll call it beta. That is the firm's exposure to the systematic risk event. And notice also that we're going to get alpha. Okay? Look at what we've done here. So we've estimated this equation. Ri is equal to alpha, the intercept, plus beta, the slope, times the proxy for the systematic risk event. We have some error terms there, right? And notice that what we've done here is we've effectively estimated equation 3. Okay? However, what I've done is I found alpha, the intercept, is going to be equal to our expectation. Does that make sense? Plus beta times the market-wide or systematic risk event plus the error term. So this has super important implications. Alpha is going to equal the expected return for each asset. Particularly, once we've controlled, look, we've got the slope in there, we've plotted the data, and we've got the slope times the systematic risk event. So we're controlling for the firm's exposure to the systematic risk event, and alpha is going to generate what the expected return is after controlling for the firm's exposure to that systematic risk. That's a super important concept to understand. What we're doing is that intercept is going to give us what we think our expected return should be once we've controlled for the systematic risk event. So to the extent that we can find or at least identify all of the types of systematic risk that exist in the world, and recall that in a previous video, all idiosyncratic risk is going to be diversified away, so all that we care about is systematic risk. So to the extent that we can identify that systematic risk and control for it, then alpha is going to generate our expected return. Okay? Let me share with you a website. Some of you have got on here before. This is a website called Seeking Alpha. In fact, there's another website called Chasing Alpha. But Seeking Alpha is a company. They provide financial advice. right? So I go here every once in a while and I look at various articles that are posted. And the purpose of this particular website is for investors to try to find alpha. All right. Seeking Alpha has a conference on CNBC. They provide a conference where some of the top investors go to some nice resort and they have a panel discussion about things that we should look for when we're trying to find alpha. What do they mean? What are we trying to find? Well, we're trying to find alpha, which is the expected return once we've controlled for the systematic risk event. Now, it's important to understand, just like idiosyncratic risk can be diversified away, right? As we increase the number of assets in our portfolio and we're decreasing the idiosyncratic risk and all we're left with is systematic risk, it's also possible that alphas can be arbitraged away, all right? So let's say there's two stocks, asset one and asset two, all right? We've talked about asset one and asset two, how the co-movement between these two assets, the single factor model is going to generate positive co-movement, and that's going to harm our ability to create an optimal portfolio. However, what happens if asset one has an expected return that's risk adjusted up here, and asset two has an expected return that's risk adjusted down here? Notice that the betas are the same. I tried to draw these lines parallel. Okay, so it appears that the betas are the same, or that the exposure of both firms to the systematic risk event is the same. The only thing that's different is these alphas. So I would ask, which of these two stocks would you prefer? Stock 1 with an alpha here, or stock 2 with an alpha here? Hopefully you're answering stock 1, right? So if we have this much systematic risk, asset 2 is only going to pay off this much, and asset 1 is going to pay off this much, right? So think about what would happen here. If these alphas exist for these two stocks, asset one and asset two, the demand for asset one is going to increase, the price of asset one is going to increase, and subsequently the returns, this alpha is going to start to decrease. Likewise, the demand for asset two is going to be low, the price is going to be low, and this asset two, the returns are going to increase. Does this make sense? Until these two lines have begun to converge, okay? So what's important to understand is that when we're seeking alpha, right, when we're trying to find alpha, alpha might only exist for a short period of time until individuals come into the market. They start buying the stocks with high alpha, the demand increases, the prices increase, and the expected returns subsequently decrease. They're going to short the stocks with negative alpha. The supply increases, the price decreases, and the expected returns begin to increase until these two things converge. Until these two things converge and the alpha has been arbitraged away. Okay? So it's important to understand, just like the idiosyncratic risk is going to be diversified away as we increase the number of assets in our portfolio, the alphas probably won't stay around very long because of sophisticated investors that try to arbitrage these things away.